Hello, this is Mrs. Hickman, and in this video we're going to be talking about related rates. Related rates is a direct application to implicit differentiation, and if you can remember implicit differentiation, every time you differentiated something with a y, you multiplied it by a y prime, or you multiplied it by a dy over dt. Well, in related rates, anytime you have a variable that you're differentiating, you're going to attach that the change in variable over change in time. So, for instance, if you had x squared plus y squared equals 4, this would then be 2x times dx over dt plus 2y times dy over dt equals 0. You could also say, but it might be confusing later on, you could also say 2x times x prime plus 2y times y prime. They mean the same thing, equals 0. Okay, so related rate is anything being that has a rate of change to it. So if you see the radius is increasing at a rate of something, usually radius usually denotes r, so that rate of change for the radius would be dr over dt. Volume, if the volume is changing at a rate of something, would be dv over dt. Okay, area, if you're doing the rate of change of an area, that would be dA over dt. So everything is going to be a change in the variable over time. So how to solve related rates. So any equation involving two or more variables that are differentiable functions of time, t, can be used to find an equation that relate. So understand the problem. So you're going to be identifying what your given information is, and then you're going to be identifying what you're looking for. A picture may help. Be sure to distinguish constant quantities from variables that change over time. So you will see an example of this, like if it says the radius is 4, but the radius isn't changing, you can assume that r is 4. It's not going to be changing over time. The radius isn't going to change. It depends on the question it's looking for, but that would be an example. So only constant quantities can be assigned numerical values at the start. So please remember, do not put any variables that could change over time. Do not evaluate any numbers at the beginning. So write an equation relating the variable whose rate of change you seek with the variables whose rate of change you know. So even though you may know what dr over dt is, do not put in there until after you find the derivative. So differentiate both sides of the equation implicitly with respect to t. Be sure to follow all the differentiation rules. The chain rule will be especially critical as you will be differentiating with respect to the parameter t. So after you differentiate both sides, then you can substitute the quantities that were given in the first place. So it is only safe to do this after the differentiation step. Substituting too soon freezes the picture and makes changeable variables behave like constants with zero derivatives. Okay. So let's get started with number 1. Okay, so a gas is escaping from a spherical balloon at a rate of 2 feet cubed per minute. So right there, so gas is escaping. So that's going to be a negative value at a rate of 2 feet cubed per minute. Okay, so feet cubed, that's volume. So this quantity right here is going to be dv over dt equals, it's escaping, so it's losing at a rate. It's going to be negative 2 feet cubed per minute. Okay, how fast is the surface area? So how fast, there's your rate, how fast is the surface area? So that's going to be ds over dt. I mean dsa over dt. Shrinking when the radius is 12 feet. So we can assume that r is 12 feet. Okay, so we have the volume rate. We're looking for the rate of surface area and radius. So I'm seeing two equations that we're going to be using. We're going to be using the volume of a sphere and surface area of a sphere. So volume of a sphere is going to be V equals 4/3 4/3 pi r cubed. Okay, and then it's asking for surface area. Surface area of a sphere is 4 pi r squared. Okay. Alrighty. So I'm going to, you can differentiate both of them at the same time, but we'll start here and then we'll, Anyway, so let's just go ahead and get started. So let's differentiate this because we know what dv over dt is. So, but do not substitute it in. And remember, there's r, but we're not substituting in r just yet until after the differentiation step. Okay? So, this is going to be dv over dt. So, it's going to be v times dv over dt. Okay, this is like saying the derivative of x. The derivative of x is just 1, so this would be 1 times dv over dt. You could also call this v prime. Equals, is your variable you're looking at. So you're going to do 4/3 times 3 minus 2. So you're differentiating r. So you're going to do 4/3, bring this 3 over here, pi r squared times dr over dt. Every time we differentiate a variable, you have to write that. So then you're going to have dv over dt equals 4 pi r squared dr over dt. Okay, let's go ahead and differentiate this over here as well. So, because you're looking for the rate of surface area, so you already know you're going to have to differentiate it. So this is going to be dSA over dt equals 4 times 2 pi r. So dSA over dt equals 8 pi r. Oops, I forgot to do dr over dt here. Okay, so notice we have dr over dt repeating twice. So I'm going to go from the volume to here, okay? Because here I'm going to have two unknown. Well, yeah, I'm going to have two unknown here. Here, once you fill out everything, you're just going to be having one variable. So dv over dt is -2 equals 4 pi. The radius is 12. And we don't know what dr over dt is. Okay? Here, we don't know what anything is. So if you're confused as to where to start, that would be the place to start because you can solve for dr over dt. So after you do a little algebra here, so you're going to do 4 pi times 12 squared, 4 pi times 12 squared. Okay, this is going to give you -1 over 288 pi equals dr over dt. So now it's like a system of equations. I'm going to put dr over dt into here. So that's going to go into that equation. So you got dSA of dt equals 8 pi times -1 over 288 pi. So the pi's cancel out. There's a 12. I forgot about the r. Whoops, there's an r still there. Okay, let's go and put that there. That's 12. Okay, just forgot to bring this r down, so r is 12. Same quantity. So that's going to turn into -96 over 288, which is -1/3 feet squared per minute. Okay, if you're not sure what units to use, you would eventually be able to see all the units canceling out. So this would be, so remember we got feet cubed here and then feet squared. So that turns into like feet right here. So then you have 8 and it eventually pans out to be feet squared. Okay. Alright, so your answer is negative 1/3 feet squared per minute. Or you could also say area is square root, so there you go. Yeah, so that's feet cubed. And then over here. Yeah, here's feet here, and then that's feet squared. There you go. That's how you get your units. Okay, now we're going to be looking at a hot air balloon. Okay, so a hot air balloon rising straight up from a level field is tracked by a range finder 500 feet from the liftoff point. So let's start drawing a picture. So a hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. Level field, straight up. So this is 500. At the moment of the rangefinder's elevation angle, the elevation angle is pi over 4. At a rate of 0.14 radians per minute. Okay, so if we're writing everything down, x is going to be 500 feet. Okay, theta, or your angle measure, whatever you want to make it, is pi over 4. The angle is increasing at the rate, so that's d theta over dt, and it's increasing, so it's positive. 0.14 radians per minute. How fast is the balloon rising at that single moment? Okay, so we're looking for dH over dt. So how fast is the balloon rising? So this is going to be height h. We don't know what that is. H equals the height. And dH over dt is what we're looking for. Okay. So Pythagorean theorem is what you might be thinking of, because this is a right angle here. But you can't do the Pythagorean theorem because you only have one side. So you need to use a trig function. The trig function you use that's dealing with adjacent and opposite, or opposite over adjacent, is going to be tangent. Oh, and this is liftoff. Okay, so you're going to be using tangent of theta equals h over 500. Okay, and go ahead and solve for h. So 500 tangent of theta. Okay, differentiate, you get dH over dt equals, the derivative of tangent is secant squared, so you get 500 secant squared of theta, don't forget, times d theta over dt. Okay, now you are safe to put all your values in. So you're looking for dH over dt equals 500 feet secant squared of pi over 4 times d theta, which is 0.14 radians. And radians per minute. So dH over dt is going to be 500 times secant squared of pi over 4. So you just got to know what cosine of pi over 4 is. which is square root of 2 over 2. Okay, so if you're getting confused, you got 1 over cosine squared pi over 4 times 0.14. That's 500 times square root of 2 over 2 squared, because this means the value is squared, times 0.14. You get 500 divided by 4. So that's going to be 500 times 4 divided by 2 times 0.14. That turns into 140. 140 feet per minute. Okay. And that's how you find dH over dt. Okay, so let's keep on going. When a circular plate of metal is heated in an oven, its radius increases at a rate of 0.01 centimeters per second. Okay, so you see a radius, it's a rate, so that's going to be dr over dt, and it's going to be positive 0.01 centimeters per second because it's increasing. At what rate is the plate's area increasing when the radius is 50 centimeters? Okay, so we get a circular plate, we got dr over dt, and we got a radius of 50 centimeters. Well, it's wanting area. So let's look at the area of a circle. The area of a circle is pi r squared. So A equals pi r squared. Differentiate, dA over dt equals 2 pi r times dr over dt, which equals 2 pi. R is 50 centimeters times dr over dt, which is 0.01 centimeters per second. So that is going to turn into, looks like pi. 2 times 50. Leave your pi's there if you can. 0.01 is 1. So you're left with pi centimeters squared over a second. Okay, next one. Okay, so this one's going to be using similar triangles. So let me do a quick overview of similar triangles. So let's say you have a triangle right here. Okay? And it's 1 to 2. Well, if this triangle, so this is 1 to 2. This triangle is 2 to 4. Okay? So you could look at it like this. You could look at it as 1/2 equals 2 over 4. Okay, so we're going to be using the same property, so 1 over 2 equals 2 over 4. We're going to be using the same property in this example here. So, water runs into a conical tank at a rate of 9 feet cubed per minute. So right there you see feet cubed per minute, that's dV over dt. And it's running into, so it's positive. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the water is 6 feet deep. Okay, so we're going to be comparing notes here. So we're looking for dH over dt. How fast is the water level rising? Okay, so let's draw our picture. Apologies, I am not the best artist. So it's pointing face down. Okay, so if you look here, so the tank stands point down. It has a height of 10 feet and a base radius of 5 feet. Here, and then we got here. Okay, so let's look at this as a triangle. Okay, so the tank stands point down. It has a height of 10 feet. So this is going to be 10 feet right here. Okay, and it has a base radius of 5 feet. Okay, now it wants us to know how fast the water level is rising when it is 6 feet deep. So we're right here. That's 6, and this whole thing is 10. So looking at similar triangles, we have R over H. Okay, that's what we're going to be comparing it to. R over H equals 5 over 10. Okay, so we're going to go ahead and solve that for R. So R equals 5H over 10, which is going to be H over 2. Okay, and you're going to see why we're solving for R rather than H when we do the volume of a cone, which is V equals 1/3 pi R squared H. And this is the reason why, because that R is squared. If you were solving for, we could have solved for H, but it's going to get a little bit, it'll be harder if you do it that way. But I'm sure you can do it that way if you want to. Okay, so that's a constant. So we're going to turn R into H over 2. Not doing any differentiation yet. We're just going to have too many unknown variables, so we're just substituting some things in. Okay. Now, if you simplify that, you're going to have V equals 1/3 pi H squared over 2 times H. So V is going to be 1/3 times 1. No, that's 2 squared. So we're going to have pi H cubed over 3 times 4 is 12. Okay? So now we're going to differentiate that. So differentiating that, so differentiating V is going to be dV over dt. And bring the 3 down, you got 3 pi over 12 H squared times dH over dt. So dV over dt equals pi over 4 H squared times dH over dt. You could have went ahead and substituted values in there. So that's going to be 9 equals pi over 4 H squared, which is going to be 6. So H is 6 right here. We're looking for the height. So water level rising, H is 6 feet deep. Times dH over dt. Okay, so then we got, separate dH over dt. You're going to have 36 divided by 4, which is 9. So you have 9 equals 9 pi times dH over dt. So dH over dt is going to equal 1 over pi feet per minute. Okay? Okay, so let's say you didn't know which one to solve and you wanted to solve for h. It probably would have... Yeah, it's different because the radius wasn't... You want h because it's giving you the height. That's why you solve for r here. Because this height, rising at 6 feet deep, h equals 6 here. So remember, this is similar triangles. So this is just a smaller one than this big one here. Okay? So, R over H equals the size of the tank, 5 over 10. Solve for R because you're given what H is. It's wanting what is the water level rising when the water is 6 feet deep. So it's wanting to know what the rate is when it's right here. So you use the volume of a cone. This is simplifying it. This is taking the derivative. There's H right there. dH over dt. dV over t is given as 9 feet cubed per minute. And that's what you get. Okay, police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving east. So let's start diagramming this. Made that a little bit too. Okay, a police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.6 miles north of the intersection, okay? So here's a police cruiser. He's y equals 0.6 miles north of the intersection, and the car is 0.8 miles east. So here's the runaway car right here. The police determine with the radar that the distance between them and the car is increasing at 20 miles per hour. Okay? So distance between that, so remember vectors, this plus this is this, the resultant. So dr over dt is 20 miles per hour. If the cruiser is moving at 60 miles per hour, so dy over dt equals 60 mph, this is miles, that's miles. What is the speed of the car? So you're looking for dx over dt equals, I don't know. So we need to find r. So r is x squared plus y squared, so that's going to be 0.8 squared plus 0.6 squared, which turns out to be 1. That's easy enough. And then we're going to use that same formula down here, because you're looking, what is the speed of the car? Well, the best way to find that is using the Pythagorean theorem, because this is a right triangle. So you have r squared equals x squared plus y squared. Okay, differentiate everything. So you're going to have 2r times dr over dt equals 2x times dx over dt plus 2y times dy over dt. Okay, you can go and get rid of the 2's if you want to. They're all going to come out, or you could just leave them there. So 2 times 1 times d over dt is 20 equals 2 times 0.6 times 60 miles per hour plus 2 times y. Oh wait, I think I did it backwards. 2x is 0.8. Sorry. This is 0.8. And we're looking for dx over dt. So 2 times 1 times 20 equals 2 times 0.8 times, we don't know, plus 2 times 0.6 times 60. Okay, so that's going to give you 40 equals 1.6 dx over dt plus 72. do a little bit of algebra, you get dx over dt equals 70 miles per hour. Okay? And that completes related rates. So please see RenWeb for your homework. Have a good night.